Number 3, we got a cliff. We're throwing it up off the top of the cliff at 10 meters per second. The cliff is 10 meters tall. It wants to know how long is it in the air, how high does it go, how fast is it going. So the things that I know, its initial speed is 10 meters per second. The acceleration is a negative 9.80 meters per second squared. And there is multiple ways to do this problem. For part A, to figure out the time, I could go like this. I could figure out how much time it takes to go from here to here using VF equals 0. And then I could double that, and that'll tell me how long it takes to go to there. And then I could figure out how much time it takes to go from here to here, where the initial speed would be negative 10, the displacement, negative 10, the acceleration, negative 9.8, and go through it. But so you could do this in 3 parts, or you could do it in 2. I'm going to do it in just 1 because I know how to do this stuff. So I'm going to say my displacement is negative 10 meters. It's going from here down to there, and that's a negative 10 meters. So I'm going to plug it into everything, and I'm looking for time. The one that doesn't involve final velocity. So d equals VIT plus 1/2 AT squared. That's my horse. My displacement, negative 10. Initial velocity, 10. 1/2. The acceleration, negative 9.8 t squared. So I recognize this as a quadratic. I've got 2 variables. There's just 1 variable, but there's 2 of them. It's not as easy as it could be. So I'm going to do a little moving around. So 1/2 times negative 9.8 is negative 4.9 t squared. I'm going to put that out front. And then I've got the 10t. And then I'm going to take this 10 and move it to the back, plus 10, and that equals 0. So what I've done is I've made a quadratic equation. This is back from your days in algebra, where I've got a quadratic equation. This is A, this is B, and this is C. From that, and if you remember back in the day, the quadratic formula said this. It was negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what I got to do. So I'm going to roll back here and take this on. There's other ways to do this, but I'm just going to go right through this problem. So negative 10 plus or minus the square root of b 10 squared minus 4 times a, negative 4.9 times c, 10 squared minus 4ac all over 2a. Oops, but a in this case is negative 4.9. So what I'm going to do, simplify this just a little bit. So I'm going to take, so 10 squared is 100, so it's negative 10 plus or minus the square root of 100. Negative, so 4 times 4.9 times 10 is 196. So a negative times a negative is a positive, so that's plus 196 all over negative 9.8. So 100 plus 196, so that's negative 10 plus or minus the square root of 296 all over negative 9.8. And the square root of 296 is 17.2. So it's negative 10 plus or minus 17.2 over negative 9.8. Now, I'll tell you right now that time can never be negative. So if I took negative 10 plus 17, that's going to be a positive number. Divide by a negative number, it's going to be negative. So I know that I can't add. I have to subtract. So negative 10 minus 17.2 is a negative 27.2. Divide by negative 9.8. So negative 27.2 divided by negative 9.8. And you get 2.78. That's how long this is in the air. 2.78 seconds. So I can go back up here. How long is this in the air? 2.78 seconds. Time. I can go over here. Now that I know it. 2.78 seconds. How high does it go? Well, maybe I'll just skip that for right now because I know that VF, that's how fast it's going at the end. So I might just skip to letter C. So how fast is it going? VF equals VI plus AT. So I'm looking for the final velocity. I know the initial velocity is a positive 10, the acceleration negative 9.8, and the time 2.78. So negative 9.8 times 2.78, and then 10 plus that, so 10 plus my answer, negative 17.2. So that's how fast it's going. So how fast is it going? 17.2 meters per second down. Okay, and then part B, how high does it go? That's kind of an ambiguous question when I ask that. Is it referring how high from the top of the cliff, or is it how high from the bottom of the ground? I guess I could go either way with this. You know, I'm not really too particular. So here, when you do this problem, you're going to want the initial velocity to be 10. The final velocity is 0. That's how fast it's moving at the very top of this. The acceleration is still negative 9.8. And what's the distance? So I'm going to use the one that doesn't involve time, and that's VF squared equals VI squared plus 2AD. 0 equals 10 squared plus 2 negative 9.8D. So 100 divided by 19.6. And I get 5.10. So the distance is 5.10 meters. Now that's 5.1 meters above the cliff. So 5.10 above cliff edge, or 15.10 above the bottom. So either one of those is acceptable.